Have you heard about this new Terraform Stacks thing? Well, today we're going to learn about it. What's up, everybody? It's Ned Bellavance, nedinthecloud.com. Today, we're going to be talking about a feature that's in preview called HCP Terraform Stacks. But before we get into Stacks and what they offer, I want to mention two quick things. I made a video a while ago about the Terraform Authoring and Operations Professional exam, or TAO Pro exam is what I called it. And although I haven't written a study guide for it, a good buddy of mine has. So Matthias Fjellstrom, I struggle with that last name. Sorry, Matthias, but he has written an excellent guide and it is available on LeanPub. So I'll include a link down in the description. And I have a video coming out where I talk to him about that study guide and what's included. So definitely want to check that out. I also want to direct you to one of my podcasts. We have been doing these really good episodes on day two DevOps. So if you're in the DevOps field and you want to know more about different products or just the experience of working in DevOps, please check out that. There's a link down in the description as well. Without any further ado, let's get into HCP Terraform Stacks. Before we get into the code, I need to set the stage a little bit for the motivation behind Stacks and what problems they're trying to solve. The best way to think about Stacks is rethinking the use of the root module. It's pretty common today to basically have the root module be the glue between all the different child modules you're using in your configuration. So you'll take modules from the public registry, maybe some that you have published privately, or ones that are even in subfolders of your configuration. And the point of the root module is to really be that glue to pass values from one module to another to construct the infrastructure that you actually want to use. There are a few problems with that model. One is deploying multiple environments is still not a solved issue with that. If you want to use the same configuration to support multiple environments, you'll need to do that through branches or folders or something in your automation software. Another problem is state bloat. The more resources you add, the more modules you add to that root module, they all exist in the same state data. And that state data can get bigger and bigger. And when you try to run a plan, it needs to pull all of the resources that are included for updates from the target platforms that are used by that root module. And that can take a really long time to actually pull all those things. Also, the more resources tends to add some time or slowness to the calculation for the plan. So those are some of the problems that you're probably dealing with. There's also a sequencing issue. So there can be times where one resource that you want to deploy is reliant on a provider that can't be configured until another resource in your configuration has been deployed. So you can't do a successful apply the first time. You have to do almost a two-phase plan and apply to get everything deployed. And you can get around that with scripting and automation pipelines or breaking it up into separate configurations. But if the two resources really should be managed in the same config, it's difficult to do that with the root module. So those are some of the challenges that Stacks is meant to fix. So with that in mind, think of Stacks as a reimagining of the root module. Now let's talk about the actual bits and bytes that go into Stacks. Okay, with that preface out of the way, Stacks are a construction in HCP Terraform. So it does require HCP Terraform or Terraform Enterprise for you to use Stacks. And that's because the implementation of Stacks is outside of Terraform core. So it needs some other bits and bytes to actually implement what Stacks do. Stacks has two main concepts that you need to get your head around. One is the idea of components. And components kind of map to those child modules that go in your root module. They're the different layers that build your application. And each component is going to refer to a module that you're trying to deploy. The other big concept is deployments. And deployments represent either an environment or a location where you want to deploy your stack. So you could have a dev, a QA, and a prod, or you could have East US, West US, and Northern EU or something. Or you could do a combination of both. So those are the two big ideas to keep in your mind. There's components that build your stack, and then there's the deployments, which are instances of that stack deployed on actual platforms. Cutting over to my code, this is a Stacks deployment that I have in VS Code. The code for this is available on a public repository, and I'll share that down in the description if you want to take this for a test drive yourself. There's some other stuff you need to do. I'll include that in the README so you can get yourself set up. You'll notice there's two new file extensions in here. One is .tfstack.hcl. The other one is .tfdeploy.hcl. .tfstack.hcl is for the components that make up your stack, and we'll take a look at the contents in a moment. The other type, the .tfdeploy.hcl, is for the deployments of your stack. So it will reference the settings that are specific for each deployment. With that in mind, let's get into the components.tfstack.hcl file. Now that I have the file open, there's a new block type here that we're introducing called component. And component takes one block label, which is the name of that component block. So you can refer back to this component in the same way that you'd refer back to a module instance. A lot of this is very similar to the information you would provide if you were just referencing a module in your root module. In fact, you have a source here. Now, in this case, the source is a local directory called network, and we'll take a look at what's in the network directory in a moment. But I want to cover some of the other arguments here. Rather than having the input variables for a module being direct arguments inside of the block, instead we have an inputs argument. And then inside that inputs argument is a map of the name of the input variable for the network module that I'm invoking and the value I want to assign it to, which is some input variables that are defined at the stack level. So just like you would define input variables for a root module, we're going to do the same thing at the stack level. And we'll take a look at which file that's in a moment. Next up, I have a providers argument. And that value is a mapping of the providers that are defined in my stack to the providers that exist inside of this component. And modules actually have this exact same argument, meta argument in them. When you're invoking a module, you can provide the providers argument to do that mapping between the providers you've defined in your root module and how they should be used inside the component. In this case, I've defined a provider called provider.azurerm.this. And that's different syntax you haven't seen before, so we'll get to that. And that's mapping to the instance of the Azure RM provider that's in my network component. Okay, now that we've seen what I'm passing to the component, we can take a quick look at what's in the network component. So I'm going to expand out the network directory. And hey, this looks an awful lot like a standard module. I've got my main, my outputs, my terraform.tf, and my variables. Let's start with what's in the main. In the main, I've got a local value where I define some naming, and then I've got some resources. I'm creating an Azure RM resource group. I'm creating a virtual network, and then I'm creating a subnet. So that's all the resources that are being deployed by the network component. If we take a look at the variables, these are standard input variables, and these are the same variables that I was referencing in the components.tfstack.hcl. So looking in the inputs, these map out to those input variables that are defined inside of my network component. And then lastly, if we look in the Terraform, I have defined some required providers, and the only one is the Azure RM provider. Just like a module, I've also defined some outputs in here, and these outputs will be exported as attributes of the component, just like you would with modules. The reference syntax is very similar. In this case, I do need to pass the subnet IDs and a subnet map because those are going to be used by another component. Speaking of which, let's go back to the components. I have defined 3 separate components in here. Let's scroll down to the next one, which is a virtual machine component. This is also sourced locally. And one thing that I want to point out here is the VNet VM subnet ID refers to an attribute of the network component, specifically the subnet ID's output, and then the first element of those subnet IDs. This creates a dependency or a relationship between the two components. There's also a lot more providers being used by this virtual machine. It's using the Azure RM, but it's also using the TLS, the random, and the mod TM, which is Microsoft Azure's telemetry provider. And that's because if we look in the contents of the virtual machine, in the main, I'm actually just using this as a thinly veiled wrapper around the official Azure verified module for virtual machine compute. And that makes use of the mod TM provider as well as the other providers that I just mentioned. Now let's look at some other files that I have in the top level of this directory that also end in .tfstack.hcl. So in the same way that Terraform will take all the .tf files in the working directory and put them together into a single configuration, you can also define your stack in separate files, and it will put all of those stack items together into a single unified stack as long as they all end in .tfstack.hcl. Looking at the other files I have in here, I have a variables.tfstack.hcl. So looking in that, these are the input variables that I am defining for my stack. And boy, these look pretty similar in syntax to the input variables you define for a root module. And that's because they are. There's really no difference here in the way that you define input variables for a stack that you would define input variables for a module. Now let's take a look at the providers.tfstack.hcl. And this one's a little bit different. Here's where you define the required providers for your stack. And you'll notice that the required providers doesn't go in a Terraform block. It's its own top level block. So that's a little change. That's a little different. But the syntax inside of the required providers is exactly the same. Scrolling down to the provider blocks, we're going to encounter some new syntax here that's different than the provider blocks you would define in a root module. The way that you give a provider an alias in Stacks is to use a name label instead of the alias meta argument inside the provider block. And I'm going to say that I like this a lot better just from a consistency standpoint. The alias for providers always felt like a bit of a kludge when HashiCorp realized you needed more than one instance of the same provider. They sort of tacked in the alias thing, but it always felt like that. It was tacked on. This feels more deliberate. So the way that you define an instance of a provider is the provider keyword, the name of the provider, and then a name label for that provider that you can use to reference it elsewhere in the stack. And then there's a config block, and that config block defines the configuration for this provider. In this case, I am using OIDC-based authentication in the stacks once we set it up over on the HCP Terraform side. Because of that, I have to set some values like use OIDC to true and set the client ID, the subscription ID, and the tenant ID. Now, you notice one other thing here, which is the OIDC token. And we haven't quite gotten to that yet, so we will backtrack to that in a moment. The other providers don't really have a configuration associated with them, the TLS and the random, but we still need to put a provider block and give it a name label so we can reference it in our components. So if we go back and look at our components again and look at the providers that are defined for the virtual machine, the provider reference is provider dot the type of provider, then the name label, which is this in this case. There is one input variable that I sort of glossed over in the configuration, and that, if we go down to input variables, is the identity token. This is the token that is produced by HCP Terraform and handed to the runner machine so it can authenticate. And so we have to give it an input variable so that that value can be set when the configuration runs. And we define how that identity token is created and assigned to that input variable in our deployments. So now it's time to talk about the deployments area. This is where you actually instantiate the stack. And I only have one deployment set up here. The deployments also supports locals, which we didn't have any locals in our stack, but we could have had locals there to create local values to interact with. In this locals block, I'm defining two local values. One is the location where I want to perform this deployment, and the other project is going to be used as a tag to apply to the resources that are deployed by the configuration. And here we have our identity token block. And this is what actually defines what type of identity token you want to be procured by HCP Terraform. What's the target that you're going to be referencing using that token? Because we're going to authenticate to Azure, the identity token type is Azure RM, and we can set the audience if you want to set it to something different inside the properties of the identity token. This lets HCP Terraform know that it has to generate this token and hand it to the worker. Okay, so below that, we have our first deployment. And the deployment has its own block type. And then the name label is the name of the deployment. And inside of it, we have to define what inputs to use for the stack so that it can actually deploy this stack. So we had our identity token input variable defined for the stack. And here we're handing it the value for that identity token that's generated by our identity token block above. Below that, we need to pass any other input variables we've defined for our stack that don't have default values. So just like you would work with a root module where you have input variables for that, these are our input variables for the stack. We have input variables for the client subscription and tenant ID for Microsoft Azure for the service principal that I'm using. And then below that, we have some more stack specific stuff, which includes the location we're going to deploy in, some information about the networking and the naming, and then also any tags that we want applied. Again, these are all input variables that are defined in the variables.tfstack.hcl. And that's it. That's everything that's in a single deployment. If I wanted to have multiple deployments, I could copy and paste this deployment block and then change the name and some of the settings. If I wanted to deploy to production or I wanted to deploy to a different location, I could change the location. I could even change the subscription that it's being deployed in if I'm working with multiple Azure subscriptions. There is one more file that is included, and it's the .terraform-version file. And this just specifies which version of Terraform should be used with this stack. And because I'm working with an alpha version of the Terraform executable, I set that version in here. And Stacks will look for this file. So you have to include this file along with everything else when you are linking the repository to a Stacks instance. Speaking of which, let's head over to HCP Terraform and actually deploy this stack. All right, over in my browser, I am logged into HCP Terraform. And if you are following along and you want to try out stacks in your organization, you're going to need to go into the general settings for your organization. And there is a stacks beta option in here. You have to tick this box in order to try out stacks in beta. Otherwise, it won't show up as a deployment option when you go into a project. With that out of the way, let's go into a project that I've prepared to use for stacks. All right, I've jumped over to a project that I've prepared to use with stacks, and it's called Stacks Test because I am extremely creative. And I'll start by adding a new stack. So I'll click on New, click on Stack, and that will walk me through the stacks process. In order to use stacks, you have to be pointed at a repository. You can't run this from the command line locally. So I already have mine connected to GitHub, and let's select the TFC Stacks demo repository, which is where my stacks information comes from. And under advanced options is a little bit about how you want to handle version control and events that happen. Do you want to track a different branch? Do you want to do branch based triggers? Do you want to do speculative plans on a pull request? I'm not going to change any of that right now. I'm simply going to click on create stack. Once you create the stack, it is going to look at the contents of your stack and build a configuration based off of what's in that stack. If there's an issue with your code, this is where you're going to find out because the configuration preparation will error if it runs into an issue with that. If the preparation is successful, then it will move to actually attempting to roll out the configuration, which means running a plan. So it's going to attempt to run a plan for my three components, the network, VM, and database. If that deployment plan is successful, then I will be able to apply that deployment plan. Looking down under the deployments rollout, I have one deployment, which is my dev deployment. That's what I would expect. And if I click through on that, it lets me know that there is a plan. So it successfully created the plan, and I can go into that plan and look at what it plans to do based off of what's in my configuration. I can further expand one of these and see all of the resources that are deployed along with that component. And down at the bottom, I can approve that plan and start deploying the components. I'll do that now. I've approved the plan. And now we'll actually go through the process of deploying the components in here. Now, if we had a scenario where one of my components was dependent on the presence of resources deployed by another component before it could actually do a successful plan, let's say I had a Kubernetes cluster in here, and I also wanted to deploy things inside of the Kubernetes cluster, but I can't talk to the API because that cluster doesn't exist yet. Stacks will do what's called a deferred plan. So it will let me know that I can't actually plan and deploy this component yet because it's dependent on resources that don't exist yet. In the next planning phase, it will do the full plan for anything that was deferred the first time around. And then I can apply those changes as well. Now, you might be wondering to yourself two important things. One, can I set input variable values for this at the stack level? And the answer is no, you can't. But you can use variable sets that have been defined at the organization level and made available to the project that houses your stack. So you can certainly do that. And there's a way you do that inside the deployment portion of the configuration to reference a variable set to get your values. So if you need to get values in another way, you can do it through that. The other question you might have is around authentication. What are my options for authentication? Well, because you can't set variable values directly in the stack, you can either use authentication values that are defined at the variable set level, or you can do the recommended approach, which is to use OIDC, which is exactly what I have chosen to do. Oh, looks like there's an error with my deployment. Let's take a look at what the error is. It says that a resource by this resource group name already exists. That's interesting. And the reason for that, because I just figured it out, is that the module I'm using to deploy the database creates its own resource group based off the name you pass it. It doesn't use the existing resource group you've already created. So, what we need to do is go back to the code and take a look inside of the database component in the main.tf. In here, I am creating a resource group, and I'm also passing it that resource group name for the module, which leads to an issue because it already created that resource group through this resource block here. So all I need to do is remove that resource group block because it's already being created by the module inside of here. And I'll go say remove resource group. I'll commit, and I'm going to do the thing you're not supposed to do. I'm going to commit directly to main. This should kick off another plan. Now, it actually did a replan on its own to make sure that there were no pending changes. So I actually need to discard this plan first and then go back to plans. And my new configuration, this will be under configuration 2. If we go back in here, oh, give me some errors as well. Well, live debugging. There's nothing like it. I removed the resource, but I didn't remove the resource group name. So this is just going to be local.name, and this one is going to be var.location. Okay, that should fix it. Fix references. See, this is why you shouldn't commit directly to main. Doing that, it will now run a third configuration, and this one should prepare successfully. So, hey, we've seen a few different failure modes here. We've seen what happens if a resource can't be deployed because there was something wrong with my config. We updated it, but then we broke the config, and it showed me that the configuration was broken. And now I made another update that fixed the configuration problems. And now we can go back down to our dev, and it shows me we're now on configuration 3. There's a plan available for that. And the only change that should be present is some changes to the database portion. It's going to remove that resource group that was created and then create the resource group and the database and everything else that is part of that. So I will go ahead and approve that plan. And now it should smoothly roll out that database. The only other thing that I want to mention briefly is the way that the authentication gets set up. And to see that, we're going to have to go over to the Azure portal and take a look at the identity and the federated identity credentials that I generated to successfully use OIDC with this stack. Over in the Azure portal, I have the application showing here that has the service principal associated with it that we're using for authentication. If we go look under certificates and secrets, there's two federated credentials here. And I just want to show you the properties of one of them so you can get an idea of what the subject identifier looks like. So it goes organization, the name of your organization, project, the name of your project, stack, the name of your stack, deployment, the name of the deployment, and then operation, what operation is approved from the token that's being handed. And so I need two of these federated credentials, one for plan and one for apply for the dev deployment. Microsoft doesn't really support wildcards. So if you're going to have multiple deployments for your stack, you're going to need to add additional credentials in here for each deployment and the plan and the apply for that deployment. Now, that might seem like a lot of work. Fortunately, I've written a module to help you out with it. Over on the Terraform public registry, I've written a module that will create OIDC credentials for use with Azure and HCP Terraform. And this supports both workspaces and stacks. And it will create the proper subject identifiers in the federated credential for either the workspace or the stacks. And that's listed down here under stacks and workspaces. So you can set one or both, and it will create a single application and service principal, and then all of those federated identity credentials to support it. I'll include a link to this module in the description as well. Okay, and that's an overview of how HCP Terraform Stacks works. I'm sure you have additional questions, and I would love to hear them. So leave them down in the comments, and I'll try to answer them as best I can. If you want to take this for a spin yourself, all you need to do is create an organization on HCP Terraform and enable that stacks. You can use the example code that I created, or there's some good examples available on the official HashiCorp documentation for stacks. So there's a couple guides for AWS, Azure, or I believe GCP. So you can kind of take it for a ride through any of those. Thank you so much for watching. I know this was kind of a long one, but there's a lot to get to in stacks, and I wanted to be fairly comprehensive. Until next time, keep calm, terraform on.